Again, the question is, how many ways are there on 7 flips of a coin to get exactly 3 heads? We can think of this. We could continue listing. This is for 4 coins. We could do 5 coins. We'd have 32 possible outcomes. Then we could do 6, which would again double the number of outcomes. We'd have 64. Then 7, we'd have 128 outcomes. Then we could try to count all the ones that have exactly 3 heads. That would get to be a clerical challenge. I don't think most of us, including me, would be very likely to get it right, even though, of course, I know what the right answer would be, so I could keep at it until I do. Okay, well, you should do that if you haven't already. Okay, the way we want to think of this, analogous to the way we thought of this, we said there are 4 slots. We want to fill exactly 2 of them with heads. Each slot could go either heads or tails. So there are 4 C2 ways to do that. Okay, now there are 7 slots with a head or tail in each. We want to pick 3 of the 7 slots to fill with a head. And of course, we'll fill the rest with tails. How many ways are there to do that? Well, the number of ways is number of combinations of 3 out of 7. We're picking 3 slots out of 7. And the order in which we pick the 3 doesn't matter. So there are C7C3, which comes down to 765 over 321, and 3 times 2 is 6, divides to 6, 7 times 5 is 35 ways. We can think of this in terms of the fundamental counting principle. Remember that 7C3, we have 7 choices for the first slot to fill, then 6 for the second, and 5 for the third. That will fill the 3 slots, but it'll fill the 3 slots in 3 times 2 times 1 different possible orders, because having filled the 3 slots, we got head in 3 of these places. Just by looking at that, we don't know which slot was filled first, which was filled second, which was filled third. Could be in any order. There are 3 times 2 times 1 possible orders for the 3 slots. So we divide the 7 times 6 times 5 ordered ways in which the 3 slots could be filled by the 3 times 2 times 1 ways in which the 3 slots that we choose could have been filled. So, and of course, we've said, okay, 7 choices for the first, 6 for the second, 5 for the third, and then we divide by 3 times 2 times 1. That's our 7C3. And that's the answer to how many ways there are to fill 3 of the 7 slots with heads. And that comes out again 35.